Hello, everyone. My name is Alireza. I'm an associate professor at the University of Tehran. Today, I'm going to talk about a research that we have recently done in the Department of Renewable Energy and Environment at the University of Tehran. It is about technology assessment of current status and future of photovoltaic technologies. So first, I would like to start the importance of renewable energy sources, particularly solar energy and photovoltaic. So as you all know, there are several concerns related to fossil fuels in terms of the availability, affordability, reliability, and accessibility of these sources such as coal, oil, or even, for example, natural gas. And recently, one of the main concerns also for the government is environmental concerns of these resources. So renewable energies are among actually serious and important strategies in order to be replaced by current fossil fuels that we are now using. So sources such as solar energy, wind power, geothermal, hydropower, or other types of the some renewables such as hydrogen or etc. are among the important sources of renewables. So one of the fastest growing renewable energy sources is solar energy and using of solar energy to produce electricity, which is a photovoltaic technologies. So there are different types of the photovoltaic technologies, depends on the materials used, the different types of the efficiency and different sorts of, for example, technologies. And it is important for us to know that how is the situation of these technologies in terms of the commercialization and which one are in our would be our in our priority for investment for for investors or end users in the market, and which are in the for example R&D development processes, or which are in the, for example, proof of concept issues and etc. And these types of the analyses that help to understand better technologies in terms of the reliability and also availability for the market. We call this a technology assessment method. So there are different types of the technology assessment tools. So we can assess a technology or evaluate or audit a technology in terms of the economic analysis. So this type of the, for example, analysis can be used by considering to several tools or methods such as cost benefit analysis or cost effective analysis, life cycle costing assessment, return of investment, net presenting value, I don't know, internal rate of return, break-even point analysis, technology value pyramid, technology balance sheet. All of them actually are the different types of the economic analysis that we can use for assessing a technology, even, for example, in solar energy or other renewable energy sources. Information monitoring, also another interesting technology assessment tools that my research group also is working um, in this area. So this it can be, for example, using different types of the methodologies, such as, for example, Delphi group, Q sorts, or it can be also joined by some other tools such as electronic databases, adaptation curve, technical scientific literature reviews, patent searches, IP asset valuations are the methodologies that can be used for information monitoring. Technology forecasting, which is actually the area of our current research, is also a types of um, technology assessment to methodology that we can analyze and understand the current situation, future of a technology. So it is a part of for example, forecasting and predicting how is the situation of the technology due to the current trend, or for example, market situation, R&D development, and etc. So S-curve analyzes trend actually extrapolation, correlation and causal methods, probabilistic methods, Monte Carlo simulation, road mappings, and HIVE, which is the focus of this presentation, are all related to technology forecasting method. You would consider or search other research that I have done recently, so you can find more about these types of the technologies. We can say about the decision analysis tools, externalities, market analysis, risk management, and also the performance analysis of technology. So some tools such as fuzzy logic, system dynamics, or multi-criteria decision makings, or can be sorted as a decision analysis, or for example, for technical performance assessment, quality function development, statistical analysis, Bayesian confidence profile analysis, trail use periods, or some technical performance as tools for risk assessment, for example, probabilities, risk assessment, environmental health and safety assessment, and for market analysis, for example, fusion method or market pull push analysis, S-curve analysis, scenario analysis. Or for externality or impact analysis, we all know about the life cycle assessment, one of the most important technology assessment tools that consider the environmental assessment or environmental impacts of a technology, or cultural assessment, ethical issues, and etc. So, and you can see that there are different types of the technology assessment tools that we can implement, and it can consider to a technology from different aspects, from economic, environmental, technological issues, risk, financial, and etc. And the focus of our research actually is the technology forecasting, and in particular, hype analysis. So yeah, as you can see here, these different types of the technology forecasting tools you can search here, you can find here. S-curve analysis, trend extrapolation, hype, correlation, and causal methods, probabilistic method, Monte Carlo simulation. There are quantitative methods of technological forecasting, right? And road mapping are all examples of technological forecasting methods that we can use. So, but the question is that what's the hype? So the fact is that when new technologies make bold promises, the question is that how do you discern the hype from what's commercially available, and when will such claim pay off, if at all? So the Gartner hype cycle methodology provide a graphical representation of the maturity and adaptation of technologies and applications, and how they are potentially relevant to solving real business problems, real technology problems, and exploiting new opportunities. So Gartner hype cycle methodology give us a kind of a view of how a technology or application will evolve over time, right? By providing a sound source of insight to manage its deployment within the context of your specific technological or business goal. So as you can see here in this figure, there are several stages for hype cycle. So mainly a 5 stage, starting with innovation trigger, and then peak of inflation expectation, truth of disillusionments, a slope of enlightenment, and plateau of productivity. So when we talk about the innovation trigger, it's a kind of a potential technology breakthrough kick things off, right? So early proof of concept stories and media interest triggered significant publicity. Often no usable products exist and commercial viability is unproven. Several in renewable energy research, we have several types of these technologies that they are in the innovation trigger, right? The second stage, which is peak of inflated expectations, talks about early publicity produce a number of success stories. So often accompanied by scores of failures. So some companies take action and may not. So truth of disillusionment is talks about interest wanes as experiments and implementation fail to deliver. So producers of the technology shake out or fail. Investments continue only if the surviving providers improve their product to the satisfaction of early adopters. The slope of enlightenment talks about more instances of how the technology can benefit the enterprise start to crystallize and become more widely understood. So second and third generation products appear from technology providers. So plateau of productivity also is a mainstream adoption starts to take up. Criteria for assessing provider viability are more clearly defined. The technology's broad market applicability and relevance are clearly clear. So in general, if I want to say, hype cycle can help us to separate hype from the real drivers of a technology's commercial promise. It can reduce the risk of our technology investment decision and compare our understanding of a technology's business's value with the objectivity of experience, for example, analysis. So I think I have talked too much related to introduction. So you can access to paper to read more about the introduction and the results. But if I want to go through it very fast about our research, actually, as you know, we have different types of the technology, PV technologies, including the first generation, second generation, and third generation. So first, when we talk about the first generation, it's a kind of semiconductor PN junction. So monocrystal, polycrystal silicons are all sorted as a first generation. The second generation is thin film solar cell, amorph silicon, copper iridium, or cadmium telluride solar cells are sorted as a second generation. And third generation is organic solar cell. Dye-synthesized solar cell and etc. So one of the most important graphs that we have in solar energy or photovoltaic technology tracking is solar cell efficient trend of report published by NREL, National Renewable Energy Laboratory of the US. So here you can see, for example, the recent progresses and the history of photovoltaic. So you can see here that, for example, what types of the solar cells were developed, and the first generations of the solar cells are here during 1975, between 1975 and 1980s. For example, you can see that how's the situation of different types of the solar cell technologies. So in the Also, the Y column talks about the cell efficiency. So currently, most of the technologies, I mean, photovoltaic technologies have the efficiencies between maybe 16 to 28, 32. There would be more, as you can see here, for example, some of the technologies, 48% even, for example, is the efficiency. But I'm talking about the market, right? And you can also see here the main developers of these types of the technologies. So, for example, RCA or National Renewable Energy Laboratory, Sharp Company, etc. So you can see UCLA or UCLA or other universities, companies. So here easily you can find that, for example, how is the situation of a technology, which is solar energy, in terms of the trends, different types of the technology, multi-junction cells or crystallized silicon cells, thin films, or emerging, for example, PV. But as you can see here, the lag for this graph is that we cannot see any track for the market. We can see about the efficiency of this. We can see that who are the developers and what's the history and trend of these technologies or these generations. But the lacking point is actually how's the situation in the market now? And is it, for example, if I want to talk about in terms of the Gartner actually stage, is it in the innovation trigger or peak of inflated expectation or truth of disillusionments, slope of alignment, or plateau of productivity? So this is the gap that we found, and we try to respond it by using technology forecasting methodology, but in a specific method, which is the hype cycle. So you can see here methodology that we have followed for this research, starting from identification of emerging technologies in solar PV. Then we determine the sub areas related to the material, installations, or other, for example, subgroups for this. Then we defined the time interval. Then we try to provide the technology life cycle diagram, as you can see here in an aerial report. And after that, we try to draw an adaptation diagram for each main technology. And then we tried also to identify the position verification. We expect a confirmation and extracting the diffusion and marketing strategies. So we have two different, in order to have hype cycle, we have two different types of the diagrams. The first diagram is a technology life cycle diagram. We call it TLCD. So the keyword, this is the steps that we follow in order to prepare the first diagram. And the second diagram is market expectation and market situation. So using some trend analysis machines, such as Google Trend, Google News, are really helpful for us to drawing the adaptation diagram for each technology. So because of the time limitation, I just want to show you the situation of some of the important technologies that we found in terms of the hype cycle situation. So as you can see here, for example, organic solar cell currently is the peak of inflated expectation. So if you find, they're talking more about organic photovoltaics. So for example, dye-synthesized solar cell now, it is now in a stage that maybe goes to the truth of disillusionments, or it can jump to the slope of enlightenment. So the commercialization for this technology is very important because it can be failed, as I said, or it can be successful if the enterprises, markets, investors try to consider it. For Amor Silicon, our analysis shows that it is now in a stage of almost a slope of truth of disillusionment, but it doesn't mean that it is completely failed. So it would jump to the slope of enlightenment soon. So the other technologies such as cadmium telluride, copper indium, gallium selenide, or other technologies, monocrystal, polycrystallized, they are in the slope of enlightenment and plateau of productivity. So as you can see here, our analysis can be really helpful to understand the um, risk of each of the technologies, because when a technology is in a slope of enlightenment or a plateau of productivity, definitely the risks would be less than, for example, if the technology is the truth of disillusionment. But on the other hand, the profit, if the success of technology from innovation trigger or a peak of inflation expectation um, increase, or we can expect that the technology prove their the ability, its ability to the market, then a huge amount of the um, profit can be gained by companies if they want to invest in such types of the technology. So this is a very fast overview of our research. Again, as I said, because of the time limitation, I try to summarize and explain more about the philosophy of our research. So for sure, you can read carefully about the results of our research in the paper and in the report. So please let us know if you have any questions related to this question, to this paper, or other ongoing projects or our ongoing research. Thank you very much and have a great day.